All right, my friends. So we're going to kick off our first lesson here for our second semester, and we're going to be on page 6 of your second semester workbook, I should say. And we're going to be looking at Geometry Unit 5, Lesson 1, and you can see that our standard for this, all right, Standard 11, Topic 1, I can find interior and exterior angle measures of triangles. So here's what I'd like you to do. You have an opener here, and you have questions 1, 2, and 3 that tie into some prior knowledge that we talked about first semester. So I'd like you to pause the video, try to answer questions 1, 2, and 3, flip it back on, and we'll see how you do. All right, so let's talk about problem 1 here. So we know A is 120 degrees, and we want to find angle B. Well, hopefully you remember from first semester that these two angles are what we call a linear pair, and all linear pairs are supplementary. So we know that the measure of angle A plus the measure of angle B is equal to 180. We know A is 120 degrees. All right, and so that tells us that the measure of angle B, if I can get my angle symbol there, would be 60 degrees. All right, so this tells us it's 60 degrees right here. All right, and then we use that same logic, all right, with angles D and E here. So we know D is 40 degrees, and once again, D and E are a linear pair, and therefore we know, because they are a linear pair, they are also supplementary. And we know if D is 40 degrees, right, and I'm writing a lot more than maybe you did, but just so you can see the whole picture here, all right, we know that E has to be 140 degrees. All right, there you go. And then on question 3, it says, using your answers above, all right, if the sum of measure B, C, and D is equal to 180 degrees, what is the measure of angle C? Well, we can see that B and D together are 100 degrees, all right, so that means that the measure of angle C would have to be 80 degrees, so that the sum of all 3 of those angles in the triangle is equal to 180 degrees. All right, now what we're hoping, all right, is that you can now make some connections between this work and a couple of relationships, all right, within the triangle. So now, once again, I'm going to have you take a look at A and B here, all right, and so I'm going to let you pause the video and see if you can come up with the relationship between A and C and D and the measures of angle E and the measures of angle B and C based on the work, all right, that we have in the picture above. So once again, go ahead and pause the video, see if you can find that relationship, and then turn it back on. All right, so let's see what we have here. So when I look, and I forgot to write this here, but we'll see that C is 80 degrees here. But when we look, all right, we know A is 120 degrees. We know C is 80 degrees, and we know D is 40 degrees. So when we look at that, right, we definitely kind of see a relationship here, right? So we can see that if I have A, it equals to the sum of C and D, all right? Let's see if that holds with E. All right, we see that E is 140 degrees, right? We know B is 60 degrees, and we know once again that C is 80 degrees. And so once again, once I write those measures in, I can see that there's definitely a relationship here. E is equal to the sum of those two angles. So there definitely looks like there's a specific relationship here. All right, and if we go up here and we look at A and E, those are actually what we call exterior angles of a triangle, right? So versus B, C, and D are interior angles. All right, now an exterior angle is an angle that forms a linear pair with one of your interior angles. And we're going to define this relationship a little bit more in just a moment with a specific name. But before we get to that, let's talk about naming triangles. Now, when we name a triangle, we use the symbol, oddly, it's a triangle. And we can just take the 3 letters that make that triangle and just use it, CAB. And the order of the 3 letters do not matter. So I could do BAC, all right? I could do ACB, all right? So what you need to understand is that the name of a triangle is not necessarily unique, all right? So somebody might write triangle CAB, somebody might write triangle BAC, somebody might write triangle ACB, but we're all talking about the same triangle, all right, based on this picture here. All right, so we just want all 3 vertices, all right, all 3 points here, all right, when we name a triangle. All right, and like I said, the order does not matter when we're just naming a triangle. Okay, so that is so we can have some common language here. Now, when we flip the page here to page 7 here, we have the triangle sum theorem. Now what the triangle sum theorem says is that every time we add the three angles in a triangle, so the measure of angle A plus the measure of angle B plus the measure of angle C, it will always add up to be 180 degrees. And this relationship is actually from some of the parallel line relationships that we developed in our first semester work, along with the fact that one line has 180 degrees in it. But we're not going to prove that right now, but it does stem from that. So the triangle angle sum theorem, all right, means that all three angles in our triangle will always add to be 180 degrees. Okay, now the triangle exterior angle theorem, this is where the opener comes in, and this is a relationship that you were developing in the opener. Now, when we talk about an exterior angle, all right, so angle 1 is an exterior angle, all right, and angle 1, the measure of angle 1 is going to equal to, and now if I go to my picture here, I'm just going to flip back to where we did. All right, we said A was equal to the sum of C and D. Now notice A is equal to C and D, but not B. And when we talked about E was equal to C plus B, and it didn't include D. Now, all three of these, all right, are interior angles. All three of those angles are inside of our triangle. Now, the way we refer to this, all right, if I look at A is equal to C plus D, based on what we developed in that, we call those remote interior angles. So it's not the interior angle that forms the linear pair with your exterior angle. So the measure of angle 1 is going to equal to the measure of angle B plus the measure of angle A. So remote, okay, remote interior angles, all right? And I'm going to write that here. So remote interior angles. All right? Now notice I could extend this side this way, and I could create another exterior angle here. So let's call this exterior angle 2 here. All right? So now when we think about this, this is an exterior angle. Now the remote interior angles for angle 2 would be angle A and then angle ACB on the inside here. All right? So these two angles would be the remote interior angles for angle 2. So the measure of angle 2 would equal to the measure of angle A plus the measure of angle, and I have to use ACB here, so we have multiple angles, all right, at that vertex. All right, so remote means that the two angles that do not form the linear pair with that exterior angle. All right, so let's just go through a couple of quick examples to see how we use those. So now if we jump down here to problem 1 here at the bottom of page 7, right, we want to find the measure of angle 1. Well, notice we know the other two angles in our triangle here. And so what we know is that 44.7 plus 52.2 plus the measure of angle 1 has to equal to 180 degrees. All right, so now if I just use my calculator here and add those together, that's 96.9 plus the measure of angle 1 is equal to 180 degrees, which means the measure of angle 1, and if I subtract those two, 180 minus 96.9 would be 83.1 degrees. And so there's our, all right, measure of angle 1. So now that was using the triangle angle sum theorem. All three angles add to be 180 degrees. All right, so you're going to have to kind of look at the picture and determine, okay, what kind of information I have, and then use the appropriate relationship, all right, to find your missing angle. So notice when I look at angle 2 here, I actually have a couple different ways of finding the measure of angle 2, and I'm going to show you kind of both ways to do this. So one is noticing I have an exterior angle. So I can use the exterior angle theorem in that I know that the measure of the exterior angle, so 124 degrees here, equals to the sum of the remote interior angle. So that would be 59 degrees plus the measure of angle 2. All right, and so I can subtract 59, so 124 minus 59, and that would be 65 degrees is equal to the measure of angle 2. All right, so I can see that angle 2 is equal to 65 degrees. And so that's using the triangle exterior angle theorem. All right, now the other thing you could have done is made this like problem 1, because we have enough information to do that. Because we know that these are a linear pair, correct? So we know that these have to be supplementary. So if I do 180 degrees minus 124, I can see that this would be 56 degrees. And then once again, now I could make this a triangle sum theorem, all right, problem, because I know that 56 degrees plus 59 degrees plus the measure of angle 2 has to equal to 180 degrees as well. And then I can see that this is 115 degrees plus the measure of angle 2 is equal to 180. And so notice I still get to 65 degrees here. All right, so either path you take, you get to the same result. All right, and so that know that you have a couple ways to check your work, but also if you get stuck, use what you know. And one of the things I always say is don't let things be a mystery. If you know how to find an angle and write it in. All right, it might not be what you need all the time, but a lot of times it will help you get to a path that allows you to find the missing angle. All right, so you work problem 3, all right, and the rest of the problems on page 8, check your work on the answer key, and I'll catch you next time.